Here we'll discuss the information typically found on blueprints. Blueprints are critical in every industry where one party designs a part, such as an engineer or architect, and another party implements the design, such as manufacturers or construction workers. Blueprints are the way that ideas are communicated. Most companies or manufacturers create drawings in accordance with a commercial industry standard, such as the American Society of Mechanical Engineers, ASME Y14. But many companies will create their own standards for internal use within the company. Regardless of which standard is used, some general concepts apply to all drawings. Most drawings are broken out into zones using a simple alphanumeric grid. This grid is critical for large, complex drawings when discussing changes or details. The grid helps drafters and engineers pinpoint where information is located. Conventional parts of a drawing include the title block, the revision block, the notes list, the field of the drawing, and the list of materials or parts list. The first place to look for information about a blueprint is on its title block. Most title blocks are located in the lower right-hand corner of the drawing. Although the title block information can vary by company, certain information is basic. The title block, at a minimum, contains a company's name and usually includes its logo and address. The drawing title block can also be called the noun or nomenclature. A short description of what the item depicted or the name of the part is typically located in this block. The drawing number gives the drawing a unique identifier as a standalone document. Older drawings sometimes use the part number as the drawing number. This is considered bad practice in modern drawing standards. In modern standards, document numbers, such as drawing numbers, should remain separate from part identifying numbers to simplify and separate both the document change and part change processes. However, drawing numbers can be incorporated into part number sequences by simply adding an extra digit to the end of the drawing number. Sheet numbering is critical when working on complex parts, as they may require several sheets of drawings. The first number indicates which sheet is being viewed. The second number indicates how many sheets there are total for the drawing. The size of the drawing indicates what size paper the drawing should be printed on to be true to scale. There are many different types of drawing size standards, but the most commonly used in the United States is the American National Standards Institute, ANSI, which is also required by the ASME Y14 drawing standard. The farther in the alphabet the letter, the larger the drawing size. The scale block indicates the size and scale of the drawing. Some items, such as large machines or buildings, are simply too large to be drawn life-size or to scale. To ensure the depiction will fit on the drawing, drafters have the choice of either drawing things to scale, larger, or smaller than the actual item. For most drawing generated by engineers, the first number on the scale corresponds to the size on the print. The second number is the size of the part. 1:1 would indicate that the drawing is full scale and that the size on the print is in the same size as the part. 1:2 would indicate that the drawing is 1/2 the size of the actual part. 2:1 would indicate that the drawing is twice the size of the actual part. Architects and civil engineers use different types of scales, as shown here. The signature block contains all signatures required for the drawing to be officially released and published by the creator. Signatures and approvals should all be signed. If they are not, the drawing may not be an official release that is ready for manufacture. Tolerances are defined as the difference between the lowest and highest acceptable limits of a dimension. It is almost impossible to machine parts to the exact dimension called out on the drawing. Tolerances allow a machinist to deviate within a specified limit that will not adversely affect the final part. The tolerances block contains the default tolerances for dimensional callouts where no tolerance is otherwise noted on the drawing. The tolerances in this block should be followed unless specifically marked otherwise. Examples of tolerances are plus or minus 0.030 or plus 1/64 of an inch. The remaining areas of the block can be tailored for other information such as material, heat treatment, finishes, weight, general specs and standards, next higher assembly information, or superseding information. Other boilerplate information such as copyright information, export control information, design activity, and manufacturing information may also be included in or next to the title block. The revisions block is a tabulated list of the revisions that have changed the original drawing. The revisions block is typically located in the upper right-hand corner of the drawing, although some drafting standards attach it in some way to the title block. The sequence for revision letters start with A as the first revision, followed by B for the second, and so on. A drawing that has had no revisions has a blank revisions block. The description area contains the general change information as well as what prompted the change. Documents that initiate drawing changes are called engineering orders, engineering change orders, or engineering change proposals. These documents are typically given a number and referenced in the description of the change on the drawing. The date and approved columns show when the change was made and who approved it. This helps to track the history of changes to the blueprint. Other information sometimes contained in this area include the zone where the change can be found, other signatures required to approve the change, and the serial number to indicate when the part change became effective. The notes list conveys information that the callouts within the field of the drawing do not. It may include general notes, flag notes, or a mixture of both. Traditional locations for the notes list are anywhere along the edges of the field of the drawing, but most are typically found in the upper left or bottom left corners. General notes apply to the entire drawing. Tolerances, general handling or material specs, color specifications, testing requirements, or packaging instructions are examples of general notes. Flag notes are notes that apply only where the flag appears in other areas of the drawing, such as the field or parts list. Typically, the callout includes a flag icon. Some drawing standards call these types of notes delta notes, as the note is indicated by a triangle in lieu of a flag. Flag notes can be annotated by either alpha or numeric characters. The parts list, also called the bill of materials or list of materials, is a tabular list of raw materials or sub-assembly parts used to make an item. Used only on assembly drawings, parts lists are typically located directly above the title block. Although some drawing standards put the parts list on its own sheet or even as a separate document. At a minimum, the parts list should indicate the quantity of parts per assembly, the part identifying number, and the nomenclature or description of the item. Most parts lists also include a material or finish description as well. Most modern drawing standards also require a dash number which helps locate the part in the field of the drawing. This item number is referenced both in the parts list and in the field of the drawing to identify the part. Other useful information typically found in the parts list are material, material specs, heat treatment requirements, size, weight, flag note indicators, and finishing processes. For drawings that show multiple configurations of an assembly, additional columns indicate the quantities of subcomponents that make up each assembly. Shown is an example of drawing with multiple assemblies. An X will indicate the appropriate quantity column per assembly. For the assembly labeled Paddle Assembly Shown, the quantity column is on the right. The quantity column for the paddle assembly opposite is on the left. In summary, blueprints are the way in which technical ideas and information are communicated from the design team to the technicians and manufacturers tasked with implementing the design.